If you're trying to figure out how to assign names to carboxylic acids, you've come to the right video. I'm James Wahlberg, and I'm going to take you through the nomenclature rules for naming carboxylic acids. Let's take a look. Of course, the most important feature of a carboxylic acid is the carboxy group. Now, thinking about what a carboxy group is, it's one carbon atom with a double bond to an oxygen and a single bond to an OH group. Well, carbon usually makes 4 bonds. Therefore, this carbon atom has only room for one more bond. Therefore, carboxylic acid groups are on the end or the terminus of an organic molecule. So what we do is we take the name of that molecule. Let's say that we have 6 carbons in hexane, and we have a carboxylic acid group on the end of the hexane. That would be hexane oic acid. We simply put the suffix oic on the end of the molecule. Now, the numbering of carbon chains begins with the most oxidized carbon. Since a carboxy group is as oxidized as a carbon can get, that means that the carbon that has the carboxy group is the lowest number. But since that's automatically the case, you don't have to put a number on the carboxy group in the IUPAC name. As with any acid, carboxylic acids can interact with bases and form salts. When they do, we change the name a little bit, and we name it starting with the cation in the salt, and then add the suffix -ate. So again, if we have hexanoic acid that interacts with the base sodium hydroxide, the salt that would be formed would be called sodium hexanoate. Now the example I've used here is hexane, which is an alkane, but of course carboxylic acid groups could appear on alkenes or alkynes as well. These same rules apply no matter what kind of carbon chain the carboxy group is a part of. So that's how to name carboxylic acids that are linear molecules. Carboxy groups can also appear in cyclical molecules. And when that's the case, what we do is we add the suffix carboxylic acid. So for example, here is hexane, 6 carbons in a ring, so cyclohexane. And there's a carboxy group on one of these carbons in the hexane chain. So this would be cyclohexane carboxylic acid. Again, remembering that we start numbering an organic molecule at the most oxidized carbon. The carbon that is bearing that carboxy group is nearest the most oxidized carbon. Therefore, that would be the lowest number in the molecule. Of course, we can have more than one carboxy group in a molecule. And if we have 2, it's a dicarboxylic acid. Here, for example, again, is hexane represented with a carboxy group on both ends of the molecule. In that case, we add the suffix dioic acid. So this is hexane dioic acid. All right, so those are the rules. It's not too long of a list. Let's apply them to a few examples. In this first example, you can see that we have our carboxylic acid group on the right-hand end of the molecule. And you can see that the longest chain has 7 carbon atoms in it. So we'll start numbering on the right-hand side of the molecule, and then we'll need to add the numbers for the names of the substituents. So over here, we have an isopropyl group, and that is on carbon 1, 2, 3. And 2 carbons to its left, we have a ketone. So this will be an oxo at position 5. Putting that all together then, this molecule is 3 isopropyl, 5 oxo, heptanoic acid. Let's take a look at another. In this example, we have a sodium salt of a carboxylic acid, so our name will begin with the cation sodium. The rest of the molecule has an ethyl group and a total of 6 carbons. So, putting that all together, we have sodium 3-ethyl hexanoate, where we've converted the end of the carboxylic acid name from oic acid to O8. In another example, we've got a cyclical compound with a carboxylic acid group on it. So we'll start here. That'll be our lowest number position. And now we've got some choices to make. The next group to pay attention to is the alkene, and we'll want to be careful how we go around this molecule. If we go around in the clockwise direction, that alkene will be numbered starting at position 3. If we go around counterclockwise, that alkene would be numbered starting at position 4. And we're interested in giving it the lowest number when possible. Let's see what else we have to take into account. Well, also on position 3, if we go around in the clockwise direction, we have an isopropyl group. And then finally, up at the top, we have a chloride. So putting that all together, we have 5-chloro, 3-isopropyl, 3-cyclohexene carboxylic acid. Notice again that we've put everything in alphabetical order, and we've ended up with the lowest numbering of the substituents around the ring. Here's one final example. In this case, we have carboxylic acids on both ends of the molecule, so this will be a dioic acid. Also, we have a methyl group and an ethyl group, and we have a ketone in the middle there. We'll have to be careful about how we number this. If we start numbering from the left, that ketone will be 4-oxo. If we start numbering from the right, it will be 5-oxo. So, picking the numbers in the way that gives us the lowest total of numbers, we end up with 6-ethyl, 3-methyl, 4-oxo, octane dioic acid. Again, putting the substituents in alphabetical order. So, I hope that gives you some experience with naming the carboxylic acids. There's a few simple rules to follow, and with some practice, I think you'll be just fine. See you in the next video.